All right, set C. Consider the following three situations. A box contains one ticket marked 0 and 9 marked 1. A ticket is drawn at random. If it shows 1, you win a panda bear. Or, box 2, a box contains 10 tickets marked 0 and 90 marked 1. One ticket is drawn at random. If it shows 1, you win a panda. A box contains one ticket marked 0 and 9 marked 1. 10 draws are made at random with replacement. If the sum of the draws equals 10, you win the panda. If you like panda bears, which box do you want? 1 and 2. What's the difference between 1 and 2? Your chances are exactly the same. Because putting more tickets in the box does not affect anything. Okay, but why do you not want 3? What's the chance of getting exactly 10 of those? It's smaller than getting the 1 in the other box. Okay. A gambler is going to play roulette 25 times, putting $1 on a split each time. A split is two adjacent numbers, like 11 and 12. If either number comes up, the gambler gets the $1 back, together with winnings of $17. If neither number comes up, he loses the $1, so a split pays 17 to 1, and there are 2 chances in 38 to win. The gambler's net gain in the 25 plays is like the sum of 25 draws made from one of the 2 following boxes. Which one and why? Okay, so here's how you have to pick a split. So the splits are 1 and 2, 3 and 4, 5 and 6, and so on. So you pick one of those. So let's say you pick 12 and 13. That's your bet. You pay $1, and if you win, you get your $1 back plus $17. Okay? So if we didn't have a roulette wheel and all we had was a box, what would be in that box? Well, how many ways are there to win? 2. So we would have 2 17s. How many ways are there to lose? 36. So that would be 3. Now, does the casino have an advantage? Yes. If you play 38 times, what would you expect to happen? We would have 2 17s and 36 negative 1s. Does the casino have an advantage? Well, 17 times 2 plus 38 times negative 1 is a $4 advantage. And that's how they make their money. Right? You have, so if you add the 17 and 17 together, you get 34. And there are actually 38 different options. So you would only win $34 and you would spend $38. So if you played 38 times, you would expect to lose $4. Yes? In like at a casino? Well, wait, say that again. Well, so the jackpots are random. Well, you think they're random. They're not actually. Um, so If you played this game, for example, could you come out ahead? Yeah, you might play once and you get a 12 and you win $17, and then you play twice and you get a 13 and you win 17 again. But the way the casino wins is if you look at everybody's play, a few people will come out ahead and everybody else will be behind. So you think that slot machines are random, but they're not. They can control where those wheels stop, which is scary, right? So there have been people that have won jackpots, and then the casino said, no, the machine malfunctioned. And they went to court and they showed them the programming of the machine, and the machine was programmed not to issue a jackpot for so many months or years. And the court said, you're right, that's a malfunctioning machine, and any machine that malfunctions is not, you can't have the winnings, and so they'll take them. Right, it's happened before. So, and what kills me is people play video poker. Right? That's a computer. They have absolute control. And if you go to Las Vegas, you will not put money in machines. They don't do that anymore. There are very, very few places that will let you put money in. It's not a token. It's not a credit card. They issue you a gambler's card, and it clips to your shirt, and it has like a springy cord, and you put your gambler's card in the machine. So you go over and you say, I want to put $200 on my gambling card. And they say, okay. And then you go over and you slide your card in the machine, and that card will track you in every machine you stick it in. So you can go play roulette, you could go play slot machines, you could go play poker, you could do whatever you want, and they watch you, and every machine is computer controlled, and they're really good at saying, well, let him win every once in a while. And they have figured out that if you win here and here, then you'll keep gambling and lose money. Everything is controlled. Anything that is computerized, they control it. Slot machines, video machines. Mm-hmm. Totally. Yep, they can totally. The electronic games are not random. They're not random. Now, the old ones where you put money in, they are more random. No, it's just a computer. Yeah. Yep. And guess what? When you come back next week, you can get a new card, but you're still the same person. So they're going to track you over your life. And I wouldn't be surprised if you go next door to the other casino, they share information. Yeah, if you get banned in one casino, then the other casinos will know about it. You know, if you try to cheat at blackjack, then you'll be banned from all casinos. Yeah, it's dirty. Don't do it. Okay, where are we? 3? Yeah. Number 3. In one version of Chuck-a-Luck, not with my own money. I was in Vegas once and my brother gave me $2 and had me put it on black and he lost. That's the only time I've ever gambled. He was like 15, so he couldn't do it. One version of Chuck-a-Luck, 3 dice are rolled out of a cage. Yeah, it was all recorded. You can bet that all 3 show 6. The house pays 36 to 1, and the bettor has 1 chance in 216 to win. Suppose you make this bet 10 times, staking $1 each time. Your net gain is like the sum of how many draws? 10 draws made at random with replacement from the box. So it would be 36, 136, and how many negative ones? 215. Is this a good game? No, terrible. You are likely, if you play 216 times, you're likely to lose like $190 something.